ساڵتان لێبێت خوێندکارانی خۆشەویست، هیوایتان دروست باشتان بۆ خوازم. من مامۆستا جیهادم، مامۆستای کیمیان بۆ قۆناغی ئامادەیی و بەتایبەتتر بۆ پۆلی 12 لە سیستەمی ئینگلیزی. پشتیوان بەخوا لە زنجیرە ڤیدیۆیەکدا تەواوی باپەتەکانی و تەواوی چاپتەرەکانی کیمیای پۆلی 12 ڕیکۆرد دەکەم بۆ ئێوەی خۆشەویست و هیوادارم سوودی هەبێت. وەگاشکرایە لاتان کیمیای پۆلی 12 لە 10 چاپتەر پێکاتووە. ئینشاءالله لە ڤیدیۆکاندا تەواوی بوردەکاریەکانی هەر بابەتێک ئەخەینە ڕوو. Let us start, guys. At the beginning, guys, prior to the discussion about the chapter 1, which is all about the ions in aqueous solution and colligative properties, I will be talking about some introductions which are must to be known by the students in order to understand the coming topics. The first one is we have to talk about the types of the compounds, and then the polarity, and then the concentration of the compounds as well. Here, guys, we have two types of compounds in terms of their structure. The ionic compounds, as you can see, the ionic compound you have studied in grade 10 or 11 are those ions or those compounds which composed of a metal. The structure is from a combination or a bonding between a metal to a non-metal. And the second type of the compound is a molecular compound, guys. And the molecular compound are those compounds that composed of two non-metals. So a non-metal with the other non-metal. Guys, the groups of compounds, those elements, the groups of elements that we deal with mainly in grade 12 are represented in these two tables. Here we have the metals. Frequently we have to know the metals of the group 1 and group 2, and with few metals in the D block as well. So here we have hydrogen, lithium, sodium, potassium, rubidium, cesium, beryllium, magnesium, calcium, strontium, barium. These are all the elements which are metal and situated in S block, and group 1 and group 2, these are critical metals to be known. And the non-metals, guys, these non-metals, the halogens, fluorine, chlorine, bromine, and iodine, with the carbon, nitrogen, oxygen, sulfur, and phosphorus. Guys, whenever there will be a combination or a formation of the bond between two of these nonmetals, like for example HCl. So H is a nonmetal and Cl as well is a nonmetal. Or SO2. S is a nonmetal and oxygen is nonmetal. The type of compound becomes molecular. But whenever the compound formed from the bonding between a metal with a nonmetal, you'll get an ionic compound. For example, Li2O, lithium oxide, or NaF, sodium fluoride, and so many other examples. Usually the first part is the cation part, which is a metal, and the second part is the anion part, which is the non-metal. Guys, in order to understand the details about the ionic compounds and molecular compounds, we have provided a few informations on each of them. Guys, you have to know the ionic compounds as ionic bonds. So the type of the bond between the ionic compound is ionic bond, And the ionic bonds are those bonds which we have a transferring of electron from a metal to a non-metal. So whenever a metal transfer electrons to a non-metal, the type of the compound is the ionic compound, and the type of the bond results the type of a bond we call as an ionic bond. For example, guys, here we have potassium. The potassium has got an electron in its valence shell, and it has tendency to donate that electron. So, and Br has 7 electrons in the valence shell. The potassium is going to transfer its electron to the Br to become 8 electrons in the valence shell and becomes positive. So whenever a metal transfer or donate an electron, the remainder becomes a positive. Why? Because the number of the protons in the nucleus of the atom predominates the number of the electrons. Why? Because in this case we have losing electrons. There will be a disruption between the numbers of electrons and protons in the atom. The same for here, guys. The magnesium is going to lose 2 electrons to the chloride, to 2 chlorine, 1 for each chlorine, and form chloride Cl2 and Mg positive 2. So the positive 2 here, guys, represent what? Represents that magnesium lost 2 electrons. 2 electrons, and the negative means gained 1 electron, and can be written as this separately or in a combined form as the MgCl2, or in the above KBr. But when we dissociate them, the metals becomes cation and the non-metal becomes anion. Examples, more examples here, guys. 2 case, they donate 2 electrons to the sulfur to get K2S. So in order to form an ionic bond between potassium and sulfur, there should be 2 atoms of potassium for every atom of sulfur. Why? Because the sulfur becomes sulfur in its outer shell. It has got 6 electrons. In order to be 8 and to meet the octet of electrons, there should be 2 potassiums to donate or transfer 2 electrons and to form K2S. And keep in mind, guys, for the ionic compounds, the conditions, the main condition is what? There should be the bond between metal and non-metal. And usually the metal is losing electron and become positive cation, and the non-metal gain electron and becomes negative, we mean the anions. For the molecular compounds, guys, we have 2 types of molecular compound. Those which are polar molecular compounds and those which are non-polar molecular compounds. We have to recognize the polar molecular compounds or differentiate between them with the non-polar molecular compounds. Why? Because the polar compounds, they do not dissolve in non-polars, and the non-polars as well, they do not dissolve in the polars. So how to differentiate between polar and non-polar? If you remember in grade 10, you have discussed about electronegativity. Electronegativity difference. Then in grade 10, it stated that if the electronegativity difference between the two atoms, the two non-metal, is in between 0 to zero point 0.3, you get a non-polar bond, non-polar covalent bond. But if it's in between 0 0.3 to 1.7, results a polar covalent bond. And if it is above 1.7, the electronegativity difference, the bond becomes ionic. So here in grade 12, it's not required to know the electronegativity difference. Instead, we have provided tips to differentiate between the polar and non-polar compounds. Let us talk about those tips, guys. The first, about the polar compounds, guys. Hydrogen with 8 atoms, with 8 nonmetals, will form polar molecular compounds always. The hydrogen with the halogens, oxygen, nitrogen, sulfur, and phosphorus. So these 8 elements, these 8 nonmetals, whenever they combine with the hydrogen, results a polar molecular compound. Examples, guys, like HCl. It's between H and Cl, which is here is given. HF, H2S, and so many other compounds, H2O. So these are all polars. Why? Because hydrogen combined with oxygen, chlorine, bromine, fluorine, iodine, sulfur, phosphorus, and nitrogen. Another tip for the polar molecular compounds is that whenever the compound contains 3 atoms of carbon, hydrogen, and nitrogen, results a polar molecular compound like CS3NH2. This is methylamine. We will be talking about that in chapter 10. And the other tip, any compound that contains COOH, which is carboxyl group, it becomes a polar molecular compound, such as CH3COOH, which is polar. And guys, you have to know polar compounds soluble in water, because the water is polar solvent, but insoluble in non-polar solvents such as carbon tetrachloride. How about the non-polars, guys? Of course, the diatomics, they're all non-polars because you'll get an electronegativity difference of 0. So all diatomics which are here is given H2, F2, N2, O2, I2, Br2, and Cl2. They're all non-polar molecules and non-polar form of the molecule. All the hydrocarbon, we mean what by hydrocarbon? We mean the carbon and hydrogen, regardless to the number of the atoms, the subscripts, you form a non-polar covalent bonds, like CH4, C2H6, C18H36, and so many other examples. Non-metal together without hydrogen. The nonmetals, when they bond together, but one of them should not be hydrogen. Like what? Like BF3, CF4, CCl4, and so many other examples. Non-polar compounds are insoluble in water. So whenever we have these groups of compounds, they do not dissolve in water. but they are soluble in nonpolar solvent, which is carbon tetrachloride. And the best polar solvent, which is mentioned in our curriculum, is water, and the best nonpolar solvent is carbon tetrachloride. And the best intermediate between polar and nonpolar solvent can be both, is ethanol C2H5OH. Guys, you have studied like, dissolve, dissolve, like. So what do you mean by like, dissolve, like? We mean a polar dissolve in polar. Non-polar dissolve in non-polar. But the polar does not dissolve in non-polar. Or the non-polar does not dissolve in polar as well. This is all about the polar molecular compounds and non-polar molecular compounds. Representation is given here, but it's due to of limitation of time, we are unable to provide more details. Guys, here in this table is important to be known. Why? Because you have studied the table of monatomics and polyatomics in grade 10 and 11. So prior to the coming to grade 12, you have to take a quick revision on the table. And the table, whether it's monatomic, we mean the single atoms, or the polyatomics, we mean a group or a cluster of atoms, they form an ion. These two should be memorized for grade 12 in order to know how to form the compounds, because we will be dealing about the groups of compounds of ionic and the molecular compounds as well. So take a quick revision. The table is given here. You have to know the name of them, the charge and their formula as well. The name, the charge and the formula. Like what? Like Mg is a formula. The Mg here, the Mg formula. You have to know the Mg is magnesium and has a positive 2 charge. You have to know this is potassium and has a positive 1. This is strontium and positive 2. And so many other examples also for the polyatomics. For example, here Cr2O7 is dichromate and has negative 2. Cn is cyanide and has negative 1. This is chromate and has negative 2, and so on. Guys, we have to talk about the concentrations. Why? Because we will be talking about the molarity and molality in the coming chapters. So we have to introduce the concentration. The concentration, we mean whenever there will be a solution, the solution has possibility to be 2 types of solution. A solution which contains a high amount of solute, which we mean concentrated, or a solution that contains a low amount of solute, which we mean dilute. So the concentration measures what? Measures the amount of solute in a solvent or in a solution. As the amount is low, the solution classified as the dilute, which means that there is a relatively small amount of the solute, and as the amount is much more, we added much more solute, the concentration becomes more, and we mean you'll get a concentrated solution. A little bit of salt, so here we have a dilute solution. but a lot of salt, when we add more salt, you'll get a concentrated solution. So the dilute and concentrated refers to the existence of solute in the solvent or the solution. As the existence becomes more, it becomes more concentrated. As it reduces, it becomes more dilute solution. So guys, if concentration is less than 1 molarity, we will be talking about molarity, we consider it to be dilute. For example, 0.99 molarity of NaCl is dilute. If concentration is greater than 1 molarity, it becomes a concentrated solution. We will be talking about that in chapter 1, section 1, the end of the section. Let us define, guys, the methods of measuring the concentration. How to measure the concentration of solution? Of course, we have 3 methods to measure the concentration of solutions. The first, molarity, the second, molarity, and the third, normality. But in our curriculum, we'll be talking about only the first and the second. It's not mentioned the third time. So the third method. What's the molarity? Molarity. Guys, the molarity represents the existence of solute in mole per volume of the solution. So, how many moles of the solute exist per volume of solution, and the volume must be in liters. The representation abbreviated the molarity by capital or uppercase M, and sometimes, guys, the mole will not be given, so asking or providing the mass, so the mole is equal to mass per molar mass. You have to know this additional equation in order to convert the mass to the mole. Let us solve an example here, guys. We have got an example. Let me here provided a sample problem, 3.5 liters of solution, 90 grams of sodium chloride, which is NaCl. What's the molarity? So capital M is the requirement, and the molar mass of NaCl is provided. The question requires the word molarity. So to solve the mathematical questions in chemistry, you have to find the relation between the given quantities and the unknown quantities. So the given quantities and unknown quantities, we use the givens to calculate the unknowns. Molarity is equal to the mole of the solute per volume in liter of solution. So which of these two given directly? Of course, the volume is given directly, so we can say 3.5 liters of the solution is given. How about the mole? The mole is not given. It's given but indirectly. So the mole is equal to mass per molar mass. And the result is what? Mass is 90 grams divided by the molar mass is 58.5 and divided by 3.5 liters. This result is the concentration of the solution, which is here we have got what? The 0.44 molarity of NaCl, and this is less than 1, so it's a dilute solution. More examples can be solved, the same method, the same technique, but the only important thing you have to know is what's the molarity and how to calculate molarity, what it represents. Let us talk about the second method, which is molality. Molality is another method which we represent the concentration of the solution by. So the molarity was mole per volume of solution, but the molality represents by lowercase m, it's equal to the mole of the solute, but per mass of the solvent in kilogram. So the mole of solute per mass of the solvent in kilograms. Sometimes, guys, the mole may not be given directly, so use the molar masses equation to convert the mass and the molar mass to the mole. But you have to know that always the mass of the solvent must be in kilogram. Okay guys, let us solve a problem, a sample problem, by to find the molality. 17.1 grams of sucrose, table sugar, is given in 125 grams of water. So this is what? This is the mass of the solvent, and this is the mass of the solute. Find the molar concentration, so m, lowercase m, when the molar mass of sugar is given, the sucrose, which is 342.34. Guys, for solving, from the question, there should be two masses. The students, they are confused sometimes. Why? Because they do not differentiate between these two masses. They convert both to kilograms. In solving the questions, the only mass which should be converted to kilogram is the solvent. So just convert the mass of the solvent to kilogram. The mass of the solute must be in grams. So do not convert the mass of the solute, just convert the mass of the solvent. Molality is equal to mole of the solute per kg of the solvent. So the mole is not given, guys. The mole is not given. Equal to mass per molar mass. 17.1, which is the mass, divided by 342.34, which is the molar mass, and divide by how many grams is given? 125 grams. You have to convert this into kilograms. So you'll get 0.125 kg of solvent, of water. And the result here we have got 0.4 molality of sucrose. We have a note here, guys. Molality is used when studying properties of solution related to vapor pressure and temperature changes. Molality, why? Because molality depends on the temperature. It does not change by changing the temperature. Molality is equal to mole per kilogram. So the kilogram of the solvent does not change with changing the temperature or the pressure as well. But the molarity, guys, which is equal to mole per volume, as you know that the volume changes as the temperature change. So whenever you study those properties of solution that related to the vapor pressure and temperature, you have to use the molality rather than the molarity. We have more sample problems, guys. The questions. This is just the introduction for prior to the chapter 1. Guys, here we will be talking about chapter 1, and chapter 1 is all about two sections. The section 1 is about the ions in aqueous solution, and the second section, colligative properties. We talked about the types of the solid. So the solid compound is divided into two types, guys. The ionic solid, we mean the ionic compound is. With the molecular solid, we mean the molecular compound is. So an ionic solid is a crystal structure, is made up of charged particles held together by ionic bonds. So the ionic compounds, ionic solids, are those compounds which held together by charged particles, by cations and anions. But unlike the ionic compounds, the molecular compounds, they composite of the covalent bonds, and they are not held together by charged particles, bonded by covalent bonds. But when we add a molecular compound, an ionic compound, into an aqueous solution, they undergo through different processes. We will be talking about each process in detail. But guys, the molecular solid is held together by non-covalent intermolecular forces. This is a statement is given in our book, guys. Said the molecular solid is held together by intermolecular force. What do we mean by intermolecular force, guys? Suppose we have HF and the other HF. Two molecules of HF. So in between two molecules we have attractions. Intermolecular, we mean between two molecules. So this is the intermolecular force. Intermolecular. What do you mean by the intermolecular? We mean the molecule of HF attracted with the other molecule by a force we call intermolecular. Inter means in between molecules. But we have another force, we mean despite of having the covalent bond, there should be a force also. We call as an intramolecular force. Intramolecular. What do you mean by intramolecular force? We mean the force between the atoms of the same molecule. The force between the atoms of the same molecule. But intermolecular force between two different molecules. That's a little bit detail about the intra and intermolecular forces. The first process, which is about the ionic compounds, is dissociation, guys. Whenever we add an ionic compound into a aqueous solution, it undergoes through a process we call dissociation. So what's a dissociation? It appears in ministerial exam questions several times. Its definition is a separation of ions. This is one keyword. When ionic compound dissolves. The second keyword. So this process specifies for which type of compounds, ionic, and what they will undergo through separation of ions. Why we use the separation of ions? Because, guys, as we add, for example, NaCl, here is a salt. As we add this salt into the aqueous solution, it separates. Prior to the addition, the compound made of the charged particles. Guys, the fly does not let me to explain. Okay. Anyway, the NaCl made up of charged particles. Here we have got NaCl, positive and negative. But when we add into the aqueous medium, into H2O, the ions, the charged particles, just separate from each other. Just separate from each other. So there were existing ions, but by adding to the aqueous medium, separate from each other to Na and Cl. K2SO4 to 2K and SO4 as well. Let us practice some examples, guys. There will be a type of question in ministerial exam question appears almost all around us, that asking by addition of an amount of a salt, how many moles of ions of cation or anion or total mole of ion will be formed. Let us practice some examples, guys. Here are the examples of the book. Write the equation for the dissolution of each of the following in water and determine the number of moles of each ion produced as well as the total number of the ions. Guys, in order to solve this types of question, the first step is to write the dissociation equation for those salts. So let us write the dissociation equation. Here we have got NH ammonium chloride, which is NH4Cl. NH4Cl dissociated to ammonium and Cl. The second method is what? The second step, is to balance the equation. You have to check whether the equation is balanced or not. And the third, take the differences, take the ratios in between each of them. So one NH4, one mole of NH4Cl produces how many NH4? Of course, one NH4 positive. How about it? One mole will produce how many moles? X. So X is equal to 1 mole of NH4 as well. So this is the mole of the cation. Let me tell you guys a tip for this. Whenever the coefficient of two substances, in an equation are equal after the balancing the equation, any amount of one of them will produce exact amount of the other. Any amount of one of them will produce exact amount of the other. What I mean is this: the coefficient of NH4Cl is 1, and NH4 as well is 1, and Cl is 1. So all the coefficients are equal. Any amount of this will produce the same amount of NH4 and the same amount of Cl as well. And for the Cl negative is equal to 1 mole. 1 mole plus 1 mole, totally the total moles is equal to 2 moles of ions. But for the next example, Na2S produces 2 Na and 1 S negative 2. The coefficient of Na2S with the S is the same. So we can say 1 mole, here it's required 1 mole. 1 mole of Na2S will produce 1 mole of S negative. So the anion is 1 mole. But 1 mole of this produces how many moles of Na? 2. And here also required 1 mole produce how many moles? 2. Of course, will produce 2. So the Na is twice as the Na2S. 2 plus 1, the total 3 moles of ions will be formed. The last one, which is about barium nitrate, dissociates into barium and 2NO3 negative. But it requires to convert or write the total moles of ions for 0.5 mole of barium nitrate. Guys, in order to solve the same procedure as the others, 1 BaNO3 by 2 will produce how many Ba? 1. So 0.5 will produce, whenever the coefficients are equal, the same, any amount of one will produce the same amount of the other. So 1 mole of Ba positive to produce it. How about 1 mole of BaNO3 by 2 produces how many NO3? 2 NO3 negative. The second ratio must be taken from the given quantity. 0.5 mole of barium nitrate will produce how many nitrate ions? This is the cross multiple method. 2 multiply 0.5 is 1, x multiply 1x. So this is the mole of the ions of nitrate. 1 mole of the anion, 1 mole of the 0.5, 1 mole of the anion, and 0.5 mole will produce 0.5 of the Ba as well. So 0.5 plus 1, the total mole of ions is 1.5 moles of ions. Let me solve one more example, guys, for you. For example, Al2 SO4 by 3. For 3 moles of sulfate, or we can say 6 moles, let me say 6 moles of SO4 negative 2, how many moles of Al2 SO4 must be dissociated? So here the process is reversed. The mole of the ion is given required to mole of the salt. First of all, we have to write the equation, the dissociation equation of the aluminum sulfate to produce Al positive 3 and SO4 2 negatives. Guys, I told you to revise the table of monatomic and polyatomics to know the charge of this polyatomic and monatomic as well. And then the next step, balance the equation. How to balance it? How many Al do we have in the reactant? 2. So add 2 to the product. How many sulfate? 3. So add 3 to the sulfate. It's balanced. The relation is between what and what, guys? SO4 is given 6 mole. 6 mole of SO4 is given. Required to find the mole of the mole of the aluminum. The mole of aluminum is requirement. Aluminum and aluminum sulfate, we can find both. So yeah, 1 Al2SO4 by 3 produces how many sulfate from the balanced equation? 3 SO4 2 negatives. Which quantity is given now? Sulfate. So below the sulfate, write 6 moles of SO4 2 negatives will produce how many moles of aluminum sulfate? 3 multiply x, 3x. 6 multiply 1 is equal to 6. Divide by 3 both sides, x is equal to 2 mole of Al2SO4 by 3. So in order to form 6 moles of sulfate, 2 moles of aluminum sulfate must dissociate and must be dissolved. The same, you can convert the sulfate to the aluminum. 2 aluminum positive 3 format 3 SO4 negative 2 or 2 negatives. About what do we have? 6 sulfate, 6 SO4 2 negatives will produce XAl positive. 6 multiply 2, 12, 3 multiply x, 3x, divide by 3, X is equal to 4 moles of aluminum. That's how we can calculate the mole of one from the mole of the other and the mole of the salt from the ions as well. We have the table of precipitation reactions. Guys, the reactions of the salts, when we have several salts, we have to provide guidelines in order to know what type of those salts are soluble and what are insolubles. In our book provides 6 guidelines in order to predict whether a salt is soluble or not. We'll be talking about those 6 guidelines in detail, but first of all, let us define the precipitation reactions. What do you mean by precipitation reaction? It's a reaction that occurs when the attraction between the ions is greater than the attraction between the ions and surrounding water molecules. Whenever we add a solute into a solvent, we'll be talking about the attractions between solute and solute solvent. There will be a precipitate. A precipitate, we mean a salt that does not dissolve and stay undissolved at the bottom of the containers or settle out. If the attraction between solvent and solute is weaker than the attraction between solute and solute, there will be a precipitate. And a precipitate can be formed from the double displacement reaction between 2 salts or many other types of reactions as well, but specifically we'll be talking about the salts. Guys, the 6 guidelines, I have distributed them into 3 groups. The first and the second, they have a common property in between. The third and the fourth, they have another common property in between. The fifth and the sixth, they have a common property as well. The common property of the first and the second is what? They are all solubles. So any compound that contains the ions of the first and the second becomes a soluble compound without any exceptions. And those ions are 6 ions only. 3 cations and 3 anions. So any compound contains sodium, potassium, and ammonium are soluble in water. Examples: Na2S, KBr, NH4Cl, and etc. The other 3 ions which, whenever exist in any compound, the compound becomes soluble, are 3 anions, which are nitrates, acetates, and chlorates as well. Examples: calcium nitrate, soluble because of nitrate. Barium acetate is soluble because it's by the acetate. Zinc chlorate, soluble because of the chlorate, and etc. As I told you, the common point in between these 2 are all soluble compounds and 3 anions with 3 cations. So we can combine all in one. We can say any compound contains sodium, potassium, ammonium, 3 cations, with the nitrate, chlorate, and acetates, 3 anions, become soluble. The third and the fourth, guys, they have another property, another common property in between. The third and the fourth, they are most solubles. 2 ions exist in compounds, usually become soluble, but with few exceptions. The first one is what? Is chloride, guys. The chloride ion whenever we have chloride in any compound, usually is soluble except 3 cases. Those 3 are what? Let me provide more details. AgCl, Ag2Cl2, and PbCl2. But you have to know it, guys, PbCl2 is soluble in hot water. So PbCl2 is soluble in hot water. Let me provide a little bit detail about the chloride on the Ag and chloride. But the examples for soluble cases, lithium chloride, barium chloride, aluminum chloride, cesium chloride, and etc. They are all usual case and are soluble. Guys, we have got 2 forms of Ag. Ag positive 2 and Ag2 positive 2. We call this Ag as mercury 2, but this one as mercury 1. Why? Because, as you know, if you remember, you studied the Stokes system of naming. The Stokes system represents the Roman numeral to the cation of the metals. Here the 2 cations is for 1 atom, but here we have got 2 atoms, 2 positive. How about 1 atom got 1? So we have to write down 1 for an individual atom, a single atom. When Ag positive 2 reacts with the chloride, result is of AgCl2, and when Ag2 positive 2 reacts with the chloride, result is of Ag2Cl2. The point is that, guys, the Ag2Cl2 is insoluble, but the AgCl2 is soluble. So the mercury 2 with chloride is soluble, but the mercury 1 is insoluble. Most compounds of sulfate are soluble except 5 ions. Except 5 ions. What are those ions? Barium, strontium, Pb, lead, calcium, mercury. Barium, strontium, mercury, lead, and calcium, they are all with sulfates. They will produce insoluble salts. Insoluble. But the other examples, like what? Like lithium sulfate, zinc sulfate, cadmium sulfate, and etc., result is a soluble salt. Let me provide a little bit detail about the mercury case with the sulfate as well. Guys, mercury, this is mercury 2, and this one is mercury 1. When mercury 2 reacts with the sulfate, result is AgSO4. This one result is SO4, 2 negatives. Result is of Ag2SO4. Unlike the case of the Cl, which the mercury 2 with the Cl were soluble, here the mercury 2 with the sulfate is insoluble, so insoluble, a precipitate. But the mercury 1, there it was insoluble, here is soluble, aqueous, it will be a soluble one. And the 5th and the 6th, they have a common point in property, which is they are most insoluble, guys. Most insoluble salts. What are those most insoluble salts? Of course, bicarbonates, phosphates, and silicates are usually insoluble, except the rule number 1, which is sodium, potassium, and ammonium. So the sodium carbonate and the potassium silicate, ammonium phosphate, they are all solubles. But the others which are represents are the insoluble one. Calcium carbonate, lithium phosphate, mercury silicate, they are all insolubles. The rule number 6, which most insoluble, sulfides. So the most sulfides are insoluble except 5 ions. Rule number 1, calcium and strontium. Calcium, strontium, sodium, potassium, ammonium, they are all solubles, but the others are insoluble. Barium sulfide, magnesium sulfide, cesium sulfide, they are all insolubles. Here guys we have a reaction between ammonium sulfide and added to cadmium nitrate. The ammonium sulfide and cadmium nitrate, when mixed, they will form a yellow precipitate of cadmium sulfide. How do we know the cadmium sulfide is a precipitate? We have a guideline which said the sulfides are soluble except calcium, strontium, sodium, potassium, ammonium. So cadmium is not one of them. Here we have got a precipitate, a yellow precipitate of cadmium sulfide by mixing the ammonium sulfide and cadmium nitrate. That's all about the guideline, the table of the solubility. We have I mentioned here the mercury 1 and mercury 2. We talked about this in detail. What's the benefit of table 1, guys? We can use the table 1 to predict what happens when two soluble ionic compounds are mixed. We will be talking about double displacement reactions between two salts. When we add two salts, what will happen? There will be a precipitate or solubles. We use the table of solubility to predict the precipitates and the solubles as well. Another point which you have to know, guys, the dissociation equations cannot be written for insoluble salts. So whenever a salt is insoluble, we are enabled to write the dissociation equation for that salt. For example, calcium phosphate is insoluble. We are enabled to write the dissociation equation for that salt. Let us talk about the questions, the types of reactions between the two salts. If you remember, guys, you have discussed about 5 types of reactions in grade 11. One of the type, it was double displacement reaction. A double displacement reaction, we mean a reaction between two compounds, which there should be switching between two ions of each compound with other. And the reaction between two salts is that type of reaction which we call as the double displacement reaction or replacement reaction. How to form a double displacement reaction, guys? Here the general representation represents as that xy plus wz. Keep in mind that always, in order to perform a reaction, a double displacement reaction, the reactants must be soluble. The reactant salts must be soluble. If there will be an insoluble salt, there will not be a reaction. And the salts, you know, guys, composed of cation and anion. First cation and followed by anion. So this X is cation and Y is anion, W is cation and Z is anion. We can say simply that the two close ions combine and the two fars they combine. So the two closes are what? W and Y. The two fars are what? Z and X. But when they combine, the cation must be written first and then followed by an ion to produce XZ and YW. The products can be soluble or insoluble. It's possible. If it is soluble, we write the aqueous solution. Aqueous, that means soluble. But if it is insoluble, we represent the insoluble by S, which is solid, and it's a precipitate. We have to predict the states according to the table. How do we know XZ is soluble and WY is insoluble? By using the guidelines in the table, which we have studied. And then how to write the overall ionic equation, guys. In order to write an overall ionic equation, dissociate the soluble salts into the ions, but let the insoluble stay unchanged. XY dissociate into X and Y because it's soluble. WZ dissociate to W and Z because it's soluble. XZ dissociate into X and Z because soluble. WY stay unchanged. Why? Because it's insoluble. That's the overall ionic equation. How to write the net ionic equation, and we'll be talking about the net and spectator in detail. But those ions that combine to form a precipitate, or we can say those ions that go through a reaction, a chemical reaction, becomes the net ionic equation. Or we can say eliminate spectator ions from the overall. What we mean by spectator? Spectator ions are those ions which appear in both sides of the equation without it passing through any change. So the fly does not let me explain. I haven't eaten anything, guys, to say I am sweet or something. So let me be in progress with the explanations on the ions in aqueous solution. Guys, there are two forces between the solute and solute-solvent. Solvent and for example, let me write AgCl with the Kf. What's the reason why when we add AgCl does not dissolve and add Kf dissolves and dissociates? There is two types of the force or attractions. The one we call as the solute-solute attraction. Solute-solute attraction exists between the molecules of the solute and the ions. If the two ions, the attractions between two ions is stronger than the attraction of the solvent to those ions, if the attraction between solute-solute is higher than the attraction between solvent-solute, so result is an insoluble salt like AgCl. But if the attraction, so here is insoluble. Why? Because attraction between solute-solute is higher than the solute-solvent. But here in this case, if the attraction between solvent-solute is stronger than the attraction between the solutes, there will be a soluble salt. So the reason behind the solubility of the salt is that if the attraction between solvent-solute is higher than the solute-solute, you'll get a soluble salt and such as K2S. If it's the attraction between solvent-solute is lower than the solute-solute, result is an insoluble salt. We have more questions here, guys. Let us practice a few questions. Stated that when ammonium sulfide and cadmium nitrate are combined, I have shown the figure above. First of all, write the formula equation. Ammonium sulfide is NH4 by 2S plus cadmium nitrate is CdNO3 by 2. And in the product, how to form this reaction? Of course, I told you the two close one combine and the two fars they combine. You'll get NH4NO3 plus CdS. And as usual, the reactant should be soluble. The product can be soluble or insoluble. How do we know are soluble or insoluble? By using the table of solubility. Ammonium, any compound containing ammonium and nitrate as well are soluble. So this is aqueous. How about sulfide case? We have this, the last guideline, it was about sulfide, said calcium, strontium, sodium, potassium, ammoniums with sulfide are soluble, but others are insoluble. So cadmium is not one of the exceptions, it's insoluble, a precipitate. How to convert this formula equation into an overall ionic equation? By dissociating those which are soluble and stay insoluble unchanged. Here we have done the overall ionic equation, NH4S CdNO3, but CdS stay undissociated, non-dissociated. Why? Because it's insoluble, and ammonium nitrate. What are the spectator? Guys, those ions that appear in both sides without any change. So NH4NO3 appears in both sides without passing through any chemical change, becomes the spectator ion, and the remainder, which is sulfide plus cadmium, formed cadmium sulfide, are the net ionic equation, guys. What's the net ionic equation, guys, and the spectator ion? The net ionic equation represents those ions and chemicals, compounds, which undergo through chemical changes. And much simpler, we can say, whenever the ions in the reactant combine to form a precipitate in the product, there should be a net, those ions with the compound becomes a net ionic equation. And the spectator ion are those ions which they do not undergo through any reaction, any chemical reaction. And for that we have three types of questions we'll be talking about in detail. But simply, the net ionic equation is equal to the overall minus spectator, or we can say the spectator is equal to overall minus the net ionic equation. That's a simpler sentence. Let us practice questions. For example, here we have K2SO4 plus barium nitrate produces barium sulfate and KNO3. How do we know that the barium sulfate is insoluble? Because the sulfate case, which said the sulfates are soluble except barium, calcium, strontium, mercury, and lead. So barium is one of the exceptions, is insoluble. Why the overall ionic equation? In overall ionic equation, dissociate all the salts into their ions, which are soluble, and stay the insoluble unchanged. Those ions that combine it and form the precipitate are classified as the net ionic equation. So here we have the net ionic equation, and the remainder, the overall minus this net, you'll get what? The spectator ions. We talked about the dissociation. It was specified for the ionic compounds, and with the ionic compound we have molecular compounds which undergo through ionization. Let us talk about the ionization a little bit and the define the ionization. Guys, ionization is the same process to form ions in aqueous solution, but is specified for the molecular compounds. Ionization, a process in which ions are formed, this is the first keyword, by the action of the solvent for molecular compounds. In ionization, we use the formation of ions, not separation of ions. Why? Because the molecular compound, they held together by covalent bonds, not charged particles, and that's why prior to the addition to the solutions, we do not have charged particles to use the charged particles in the medium of aqueous just separators. No, we do not have the charged particle. When we add the molecular compounds into the aqueous medium, they just start or begin to form ions. So that's why we use the formation of ions. When a molecular compound dissolves and ionizes in a polar solvent, ions are formed where none existed in the undissolved compound. There were non-existed ions in the undissolved form of the compound, but when we add to the aqueous medium, it just starts to dissolve and form ions. That's why we call us the ionization. Here we have a note, guys. When hydrogen chloride gas dissolves in water, HCl dissolves in water, it ionizes to form proton and chloride, but the proton immediately bonds with water to form hydronium and Cl. So this is the HCl gas plus H2O. When we add this to the H2O, dissolve to form hydronium and Cl negative left behind. For the ionization, we will be talking about the difference between ionization and dissociation in detail, but the main point is that ionization is specified for molecular compounds and there will be formation of ions, and the water will be the reactant here. But for the dissociation, it's specified for the ionic compound, and the ions are separated, and water is not a reactant, there is a medium in dissociation. HCl contains a highly polar bond, so HCl dissolves in water to produce proton and Cl, but the proton combines with H2O to form hydronium. And this process we call as the hydration. So what's the hydration process? Guys, dehydration is a branch of the solvation in chemistry. Solvation. Solvation is the attraction of the amine solvent to the other substances, whether it's ion or molecules, and attract to it and bond with it. But if we want to specify the solvent into water only, the process from solvation specified to dehydration. So dehydration is a process in which substances attracted by water, we specified that solvent, and result is the formation of a hydrated substance. The equation of dehydration represents here, guys. When the H attracted by water, the water is going to attract the proton, and then result is a hydronium, which we call as the hydrated substance or hydrated proton. Here a proton reacts or attracts by water to form a hydrated proton. And this process, guys, is an exothermic process. The energy released as heat during the hydration of the ions provides the energy needed to break the covalent bonds. So In chemistry, usually the formation of bonds is exothermic, releasing energy, but the breaking bonds is endothermic, releases energy or absorbs the energy. In this process, the H positive forms bond with the H2O. This is the hydration, and through this process, there will be a releasing of energy, and that energy the process requires to utilize the energy to break the covalent bond between the molecular compounds and ionize, increase the ionization process, ionize the other molecules. With this is all about the ionization, guys. We have the hydronium ion specifically. So what's the hydronium ion? Hydronium ion, guys, we talked about it shortly, but let us talk about the hydronium in detail. The hydronium ion, some molecular compounds ionize in aqueous solution to release proton. And guys, those molecular compounds, we can say, usually are strong acids and weak acids. The weak acids and strong acids, they have a property, they contain proton and they release the proton into the medium of solution, but the proton has no existence in their solutions. Instead, the proton immediately, simultaneously, attracted by the water molecules to form hydronium. Example, HCl, which is a strong acid, reacts with the H2O to form hydronium and Cl negative. Hydronium plus Cl negative here. And the representation here is given as the HCl with the H2O produces the hydronium with Cl negative. This HCl is the hydronium ion. So the hydronium ion can be formed from the reaction of a proton with H2O. A reaction of the proton with the H2O results a hydronium ion. Three informations are necessary to be known. First, formation of hydronium is exothermic. It releases energy. Why? Because the procedure is formation of bond. Second, hydronium composed of three equivalence covalent bonds. It composed of what? Three equivalence covalent bonds. We mean what? We mean this is the hydronium ion. We have got three equivalence covalent bonds between oxygen and hydrogens. And more specifically, we can say that the proton that combines with the oxygen, the proton that combines with the oxygen, at the beginning we have H2O, and the proton is coming to react with the H2O. Guys, H2O has got 6 valence electrons. 2 of the valences shared with 2 hydrogens and 4 valence electrons remain. And then the oxygen is going to donate both electrons or a pair of its electrons to the proton. Why? Because proton has only got one proton, has no any electrons to share with the oxygen. The third bond here, the third bond with the proton is we call specifically as coordinate covalent bond. Coordinate covalent bond. What do we mean by coordinate? We mean the bond formed between 2 atoms, but only one of them shared the electrons, not both. But still, the coordinate covalent bond, as the other covalent bond has the same strength in terms of strength, and it's equal in terms of strength. The third information is the hydrated proton. Hydrated proton, the structure of hydrated proton is here. It's given here. How to know the structure of the hydrated proton, guys? The hydrated proton followed this structure. Followed the structure of this. The number of the oxygen is n. In order to get the number of the hydrogens, multiply 2 by that n plus 1. For example, here S3O. Oxygen is 1, hydrogen 1 multiplied by 2, 2 plus 1, 3, and of course always there should be a positive ion. 2, if oxygen is 2, multiply 2 by 2 is 4, plus 1, 5. If oxygen is 3, multiply 3 by 2, 6, plus 1, 7. If oxygen is 5, multiply 5 by 2, 10, plus 1, 11. These are all hydrated proton. And the differences between dissociation and ionization, guys. There are 3 main differences between them. First, it's used for ionic compounds, the dissociation, but the ionization for polar molecular compounds. The compound must be polar. Examples, soluble salts such as NaCl, metal hydroxide bases such as NaOH. Examples, weak and strong acids such as HCl, HF. We'll be talking about those groups in detail. Molecular bases such as ammonia. The second is that H2O does not react with the ionic compounds and does not participate in the reaction for the dissociation. It must be written on the arrow, not with the reactant. But the ionization, unlike dissociation, there should be attraction of the molecular compound with water. So participate in the reaction as written on the reactant side. Here the ions are separated because there were existing ions. But there the ions are produced or formed. Why? Because there were no existing ions. Example, NaCl dissociate to Na and Cl. HCl reacts with H2O to form hydronium and Cl negative. Here we have several examples for the solutions. I will be explaining the 3 types of reactions between salt. The first type, guys, type 1, a salt, 2 soluble salts react to form a soluble one, soluble, plus insoluble. This is the first type. Whenever the type of questions is this, there should be overriding equation, net, and spectator as well. Examples for that, we talked about the examples. For example, BaCl2 plus K2SO4 produce BaSO4 plus KCl. Guys, here this is aqueous. This is a precipitate, aqueous. The overriding equation, Ba2 positives plus 2Cl plus 2K plus SO4 2 negatives will form BaSO4, a precipitate, 2K plus 2Cl. Those ions which combine it and form the precipitate Ba with the sulfate to form barium sulfate is the net ionic equation. And those ions which appear in both sides are the spectator ions. S, spectator ions. Let us talk about the second type of the questions. Second, two soluble salt react to form two insoluble salts. Insoluble. The example. In this case, for example, BaCl2 plus Ag2SO4. Result is AgCl plus BaSO4. As you know, this is soluble, insoluble. When two insoluble salt is formed from the double displacement reaction, the overall ionic equation equals the net ionic equation. Second, there is no spectator ion. And of course, the reaction occurs between those two salts. This is important to be known. There is no spectator, and the overall all becomes the net ionic equation. The third type is just the opposite of the second. Two soluble salts produce two soluble salts. For example, NH4Cl plus KF results NaF plus result is of KCl plus NH4F. This is soluble, insoluble. So the solubles, in this case, guys, all ions are spectator. When there is no precipitate, all the ions become spectator ions. Second, there is no net ionic equation. Third, if there is no net ionic equation, we can say there is no reaction. There is no chemical reaction in the process. This was about the types of the salt. The questions about the types of the salt, which this represents those types. In terms of conducting electric current, guys, the solutions divided into two groups. Those which are non-electrolyte, which they do not have ions to carry electric current, and those which are electrolytes, they have existing ions to carry electric current. And the non-electrolytes first are substances which do not yield ions in aqueous solution and do not carry electric current. Of course, those substances must be polar to dissolve and form solutions. When they dissolve, they will not form ions. So when there is no ions in the solution, there will not be the property of solution becomes a non-electrolyte which has no tendency to carry electric current. We have two groups of compounds which are non-electrolyte solutes, the sugar and alcohols. The sugars glucose and sucrose. There should be more examples, but these are the common two examples in our book, the glucose and sucrose, which is the carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. But the alcohols, we'll be talking about the alcohols in chapter 10 in detail. The general form of alcohol can be stated as CHOH. CHOH. For example, CH3OH, this is methanol. C2H5OH, ethanol. C3H7OH, propanol, butanol, and so on. So those that they have a suffix of "ol", they are alcohols, but how to know which compound is alcohol for now? The structure followed by this, CHOH. These two groups of solutes, they are not electrolytes, they do not form ions in aqueous solution. The second, which is electrolytes. And what are the electrolytes? Are those solutes which yield ions and conduct electric current in the solution. We have 5 groups of compounds which they dissolve and yield ions in aqueous solution to form a solution which conduct electric current. The strength in which substances conduct an electric current is not related with solubility. The formation of the ions or the strength of conducting electricity depends on the formation of ions, not on the solubility. There should be compounds highly soluble but does not form ions in the aqueous solution. There cannot be a strong electrolyte. Or there should be ions that are not highly soluble but form a high amount of ions in the solution. It becomes a highly or a strong electrolyte. It's related to the ability to form ions in solution. So the strength of the electrolyte depends on the formation of ions in the solution. Strong and weak electrolytes are different in the degree of ionization or the dissociation. There are 2 types of electrolytes, the strongest and the weakest. Let us talk about those, and they are different in the degree of ionization and dissociation. What are the strong electrolytes, guys? Strong electrolytes are those solutes which they form ions in their solution only, and they completely ionize or dissociate to form ions. 3 groups of those 5 are the strong electrolytes: soluble salts, strong acid, soluble ionic compounds, we mean soluble salts, and strong bases. In order to arrange this, I have stated this: 3S is equal to 1S. Means what? Means soluble salts, S, 1S, strong acid, the second S, strong base, the third S, is equal to 1S, which is soluble. So this S, 3S is equal to 1S in order to manage it. And the solutions of the strong electrolyte carry electric current well. Why? Because it has almost all the ions and all the compounds present in the form of ions. We have only got the ions in the solution. Non-ionized, there will not be non-ionized or non-dissociated compounds. For example, HCl completely ionized to form Cl and hydronium. The attraction force of water is greater than the bond force between hydrochloric acid, so the hydrochloric acid completely ionize and form ions in the solution. With the strong electrolyte, we have got weak electrolytes, guys. What are the weak electrolytes? The weak electrolyte, unlike the strong electrolyte, they exist mostly as non-ionized or non-dissociated molecules. And they do conduct electricity, but purely. So the solutions that conduct electricity purely due to the presence of small amount of dissolved compound in the form of ion. Mostly is non-ionized molecule or non-dissociated compound molecules. And those groups are weak electrolyte, weak acids, and weak bases. 2W equal to 1W. We mean weak acid 1W, weak base the second equal to weak electrolyte. And the example here, the HF with the H2O formed hydronium and F. And as you can notice, it's represented by double arrow, means the compound is ionized partially. The reverse reaction favored in this process, and the concentration of the HF as non-ionized is much higher than the hydronium and the F, the ions. So in weak electrolyte concentration, the concentration of the non-ionized molecule is much higher than the ions in the medium. Why? Because the hydrofluoric acid, the bonding force between hydrofluoric acid is greater than the attraction of water to the hydrofluoric. That's why hydrofluoric is difficult to ionize as the HCl, the above. Here we have got something about dilute and concentrated. Most of the students, they may confuse this with the strength of electrolytes. Guys, keep in mind that the strength of the electrolyte, it is independent on the dilute and concentrated. Dilute and concentrated, we talked about at the beginning of the video. We said a dilute solution is a solution that contains low amount of solute. A concentrated one contains high amount of solute. But a dilute solution, if we add more solute to the solution of any substance, the changing the solute amount does not change the property of that solute to become strong electrolyte from weak, or to become weak electrolyte from strong. So the examples here, guys, O molarity HCl with 10 molarity HCl. Guys, two terms, the dilute and concentrated refers to the amount. The strong or weak refers to the identity of the substance. Whenever the substance is weak acid, it's weak electrolyte, even if it's high concentrated. Whenever the substance is strong acid, it's strong electrolyte, even if the amount is low. So in this case, both HCl, they are strong electrolytes, but this one is dilute, this one is concentrated. For acetic acid, guys, acetic acid in both cases is weak electrolyte, even if it's high concentrated here. This is dilute weak electrolyte, this one is concentrated weak electrolyte. So the changing the concentration does not change the strength of the electrolyte from strong to weak, from weak to strong as well. And 1 molarity and above is concentrated. Below 1 molarity we call as a dilute solution. We have got solutions, questions we'll be solving, but let us talk about the differences between strong and weak electrolytes. Guys, the strong electrolytes completely ionize or dissociate, but the weak electrolytes slightly ionize or partially ionize or dissociate. Here we represent the equation by a forward arrow, there by a double arrow. So whenever the strong acid, strong base, soluble salt exist, always the favorite direction is forward, keep in mind this. And when it's weak acid, weak base, the favorite direction is reverse favorite. Contains large amount of ions, or we can say only ions, but here contains small amount of ions, mostly non-ionized or non-dissociated. Contain only ions, contain ions and non-ionized. Example, HCl with H2O formed completely hydronium and Cl, HF formed partially hydronium and F. The strong acid, strong base and soluble salts are example for strong electrolyte. Weak acid, weak bases are example for the weak electrolytes. Which one have only ion in aqueous solution? A question. Barium sulfate. This is ionic compound but is insoluble, so it's incorrect. KCl is ionic compound and also soluble salt. Yes, it's correct. C6H6, this is benzene. We'll be talking about it. It's hydrocarbon. It's non-polar, cannot dissolve. Ammonia? No, it said only ion. Whenever it says only ion, you have to choose strong acid, strong base, soluble salt. But if it says the only ion and ionize, only ion and ionize, strong acid is the answer. Second, only ions and dissociate, strong base plus soluble salt. Third, ions plus non-ionized, this can be weak acid plus weak bases. High concentration of the non-ionized or non-dissociated than the ions must be weak acid and weak bases. So these are can be asked in ministerial exam. Another question is about what? 1.5 molarity of HCN is what? Guys, the concentrated and dilute must be decided from the amount. The strong and weak must be decided from the property of the compound. 1.5 is above 1, so it's concentrated. A and C must be cancelled. The two remains B and D, concentrated. HCN is weak electrolyte. Why? Because it's weak acid. Weak acid. And the weak acids are what? Weak electrolyte. So D is the correct answer. We have decided about this concentrated from the amount, the weak electrolyte from its property. Prior to the solutions of the questions, I would like to talk about those groups of compounds in the first section that we deal with. We talked about sugar and alcohol. You know probably what are the, but let us talk about the acids, bases, weak and strong, in order to be prepared for the coming chapters, guys. The compound is composed of the ionic and molecular. We have two types of compounds, ionic or molecular compounds. The ionics, guys, the ionic compound, we have strong bases, soluble salts, and few weak bases. How to know which group of compound is strong base? Group 1 plus hydroxide Group 2 plus hydroxide, except Mg and Be are all strong bases. For example, lithium hydroxide, sodium hydroxide, calcium hydroxide, barium hydroxide, cesium hydroxide, and so on. These are all strong bases. Simply, that's all about the strong bases. I will not be talking about the soluble salts. I will be talking about the soluble salts after the acids. Few weak bases, simply the few weak bases are those compounds which are what? D block element, D block plus hydroxide. Why? Because usually the D block metals, when they combine with the hydroxide, they will be very low soluble in water, and when they are very low soluble in water, they will not produce a high amount of ions. Example like copper hydroxide, iron hydroxide, zinc hydroxide, and so many other examples. The D block element with the hydroxide are weak bases but ionics. How about what are the moleculars? We have got three groups of the molecular compounds, four groups in detail. Sugar plus alcohol, which are non-electrolyte. The strong acids, weak acid, and molecular weak bases. We said the sugar can be the sugar C6H12O6, the carbon, hydrogen, oxygen, alcohol C2H5OH, CHOH. The strong acids, guys, we have got two types of acid for the acids: binary and oxy. The binary acids in our book are 5 binaries. 3 of them are strongest, 2 of them are weakest. HCl, HBr, HI, they are all strong binaries. And HF, H2S are what? Are weak binaries. How about for the oxy acid, guys? Oxy acid composed of oxygen and hydrogen always. The number of the oxygen minus the number of the hydrogen, if it's above 1, oxygen minus the hydrogen, if it's above 1, it becomes a strong. But if oxygen minus hydrogen less than or equal to 1, 0 and 1, it's weak. Let me provide examples. For example, H2SO4. 4 minus 2 is 2, so it's strong. HNO3. 3 minus 1, 2, so it's strong. For example, more examples. HBrO4. 4 minus 1, 3. HClO3. 3 minus 1, 2. These are all strongest. How about the weak oxy acids? H3PO4. 4 minus 3, 1. It's weak. H2CO3. 3 minus 2, 1. It's weak. HBRO. 1 minus 1, 0. HiO2. 2 minus 1, 1, so it's weak. How about the molecular weak bases? Molecular weak base, ammonia and any compound contain carbon, hydrogen and nitrogen, like CH3NH2, C18H21NO3, and C6H5NH3 or NH2. So many other examples. Amine, codyne, aniline, so methylamine, ethylamine. We'll be talking about the amines in detail. So guys, these are the types of the compounds which we have in detail. How about the salt? A salt is a combination of the acids with the bases. But what's the difference? The difference is that for the salt is cation of base plus an ion of acid combine to form salts. Combine to form salts. Let me provide examples. Acid or base, acid, salt. KOH, NH3, NaOH, CaOH by 2, HF, HCl, HNO3, H2SO4. How to form the salts? The cation, the anion of the acid combines with the cation of the base. So KF, NH4, the NH3 becomes NH4 in aqueous solution, NH4Cl, NaNO3, CaSO4. These are all the salts. That was about the salts and all the other compounds in our book. Guys, here we have got some questions. What happened when HF, hydrofluoric acid, dissolved in water? Hydronium forms? Yes, of course. The resulting solution conduct electricity? Yes. Most of the acid remain as molecules? Yes, so all of the above is correct. According to the general solubility rules, which one is true? Any NO3 is soluble. Sodium, yeah, it's true. Barium sulfate is soluble. No, it's insoluble. Cadmium sulfide is soluble. No, it's insoluble. AgCl is soluble. No, it's insoluble. Which solution contains the strong electrolyte? Strong electrolyte can be strong acid, strong base, soluble salt. A is the correct answer. Question 4. Which solution would not conduct an electric current? So it has no tendency to conduct electric current. KCl is a soluble salt. BHBr, strong acid. RBCl is a soluble salt. C6H12O6 is sugar, so it does not conduct electric current. Which of the following is a spectator ion? Spectator ion. The spectator ion, those ions which appear in both sides of the equation without any change. So the PbI2 is the net nitrate and the other is Na are the spectators. So A is the correct answer. When NaBr dissolves in water, which of the following does not occur? Does not occur. So this is the keyword, guys. The compound ionize does not occur ionization. Why? Because the compound is ionic, is not molecular. The compound dissociates, yes, it does occur. Hydration forms, yes, there will be hydrated salts. Uniformly mixed means it's a solution, yes, of course. Which of the following compounds is insoluble in water? Insoluble. According to the table of solubility, you are able to, those that contain nitrate are soluble, sodium are soluble, ammonium are soluble. So lead sulfate is one of the exceptions of the sulfate is insoluble. Which of the following dissociates in water? Dissociates means soluble salt or strong bases. A is the correct answer. Which ions does not appear? Does not appear, this was the ministerial exam question, appears in ministerial. Does not appear means spectator ions. So spectator ions, these two salts will form NH4NO3 and ZNS. The spectator ion in this case are the NH4 and NO3. Why? Because ZNS is insoluble. This is soluble. So NH4, NO3 is the correct answer. Which of the following is the hydronium ion? Of course, C is the hydronium ion. Other questions according to the given overall ionic equation, which one is wrong? BaSO4 is precipitate. Na and Cl are solubles, yes. SO4 and Cl are spectator, no, it's not spectator, so this one is wrong. BaSO4 is insoluble, yes, it's true. Precipitation is an example of double displacement reaction. Which of the following pairs of solution produce a precipitate when combined? When combined, you'll get BaNO3 and NaCl. It will not form a precipitate. NH4NO3 AgCl, yes, AgCl is a precipitate. NaCl KSO4 is not a precipitate. CuCl to NaNO3 is not a precipitate. Ions are formed from solute molecules by the attraction. This was a ministerial exam question. Ions are formed by the attraction of the solvent is ionization, of course. The separations of ions, this is the definition of the dissociation, separation of ions. Spectator ions in the reaction between the aqueous solution of zinc nitrate and ammonium sulfide. Zinc nitrate, ZnNO3 by 2 plus ammonium sulfide, NH4 by 2S. So the ammonium nitrate will be formed with the zinc sulfide. It requires the spectator. The spectator ions are ammonium and nitrate. That's the end of the chapter 1, guys. Here we have got some ministerial exam questions. Appears in ministerial exam question. What's the net equation for the precipitation of nickel 2 sulfide? Of course, whenever such questions asked, there should be the ions of that salt in the reactant and the precipitate of the salt in the product. So the correct answer is A. Why? Because the ions appears in the reactant and the precipitate in the product. But why here is not correct, the ions in the reactant? Because it's solid in the reactant. The ions must be aqueous. And the other ones are incorrect because includes the other ions which are not in the nickel sulfide. What precipitate form when a barium chloride and sodium sulfate? Barium sulfate is a precipitate, yes, of course. BaSO4. And what's the spectator ion? Spectator ion will be the NaCl. Na and Cl is the correct answer. The solution of barium chloride and sodium sulfate is mixed together. If so, the net equation, the net ionic equation is what? Here we have barium chloride and sodium sulfate. You'll get Ba positive 2 plus SO4 two negatives to form BaSO4 insoluble. This is the correct answer. So the Ba here, the second, the B is the correct answer for the above question. This separation of ions that occur when an ionic compound dissolved in water is called as what? As dissociation, of course. Ions are formed from solute molecules by the action of solvent. This is ionization. Which of the following ions does not appear in the net ionic equation? Meaning the spectator ions. Of course, the sodium and nitrate, A is the correct answer. Spectator ions in the reaction between the aqueous solution of zinc nitrate and ammonium sulfide are the zinc nitrate and ammonium sulfide. They will form zinc sulfide and ammonium nitrate. The ammonium and nitrate, they become the spectators. Ammonium and nitrate. So C is the correct answer. Which of the following is a molecular compound and ionized in water? Molecular compound, the first key, and ionized in water. NaCl is an ionic compound. C6H6 is molecular compound but does not ionize. NH3 is molecular compound and ionizes. So D C2H5OH does not ionize. Why? Because we talked about the alcohols. That we said the alcohols, they do not have tendency to form ions. Which pair of the solutions, when mixed, form a precipitate? This is simple, guys. NaSO4 with KCl is not a precipitate. KNO3 FeClO3 is not a precipitate. NH4CO3 and KBr is not a precipitate. Ag with the S, because with the NaNO3, IgS is a precipitate, so the D is the correct answer. Which of the following pairs represent the precipitation after mixing? The same mechanism of the above one. NaNO3 CuCl2 is not. MgNO3 by 2 and FeCl2 or Cl3 is not. KNO3 CuCO3, this is the formation of the copper CuCO3. So if you remember, carbonate is there insoluble except sodium, potassium, ammonium. So the C is the correct answer. NaCl and CaNO3 is soluble. Separation of ions. Whenever it talks about the separation of ion, there should be dissociation, guys. And how many moles of ions present totally in aqueous solution of calcium nitrate? Calcium nitrate produce 1 calcium plus 2 nitrates, so totally 3 moles of ions. Which of the following is the molecular compound and ionized in water? Should be molecular compound and ionized. B is the correct answer. Why? Because weak acid, they are molecular compound and ionized. The same question 14. Which of the following pairs form a precipitate after mixing? Of course, we have to check CaCO2 is not. CuCO3, copper carbonate, yes, it forms a precipitate. Calcium nitrate, NaCl, no. MgNO3 by 2 and FeCl2, no. So the correct answer is B, which form a copper carbonate precipitate. How many moles of dissociated calcium chloride are required to produce 2 moles of chloride ion? So calcium chloride, CaCl2, will produce Ca 2 positives plus 2 Cl negative. Says 2 moles of chloride. If 2 moles of chloride will be formed, what will be the mole of the CaCl2? Of course, 1 mole of CaCl2 must dissociate to form 2 moles of chloride. And guys, which of the following can undergo ionization? All molecular compounds? No, because we have sugar and alcohol, they do not undergo ionization, and molecular compounds. Molecular compounds that are electrolyte, yes. Any molecular compound which is electrolyte is undergo through ionization. All polar molecular compounds, no. Sugar is polar and does not undergo. All mentioned, so B is the correct answer. Thank you for the attention and hope it makes sense for you. We will be in progress with recording the other sections in the coming days.